understand why small pH changes are so concerning, we must look beyond chemistry and towards the physical collapse of our coastlines and the direct threat to human society. Prior to industrialization, the global average of ocean pH was stable at approximately 8.29. According to the EPA, this has since dropped to 8.1 due to human carbon emissions. While the shift may seem minor, pH is logarithmic. This means a zero point 0.1 change in pH actually translates to a 30% increase in ocean acidity. Under normal conditions, the ocean maintains a steady supply of carbonate and calcium ions in addition to other molecules such as water, H2O. However, excess carbon dioxide from human activities reacts with water and creates carbonic acid. This carbonic acid dissociates and releases hydronium ions. These ions aggressively bond with carbonate to form bicarbonate, creating a scarcity of the carbonate needed for calcification. Calcification is the process where organisms such as shellfish, algae, and coral use calcium ions and carbonate from their natural environments to build protective skeletons. However, in this acidic and corrosive environment, marine creatures' lives are threatened. Coral structures, for example, not only dissolve faster than they can rebuild, but they're also unable to properly build their complex structures, causing reef populations to shrink. Shift is critical because as coral structures lose their three-dimensional shapes, the physical protections they provide to our shorelines also vanish. Healthy reefs, in general, act as natural resistance, dissipating up to 97% of wave energy. When acidification flattens these reefs and reduces their rugosity or roughness, they lose the friction necessary to slow the ocean. This allows more powerful waves to reach back wave environments, accelerating coastal erosion and the stripping of sand from beaches. Furthermore, because acidification prevents reefs from growing vertically along rising sea levels, the ocean becomes deeper over the reef, leaving coastal communities increasingly vulnerable to the unshielded force of the sea. Ultimately, ocean acidification travels upshore, threatening human safety and global economies. As natural barriers fall, we face billions in property damage from flooding to storm surges. Beyond physical safety, the collapse of calcifying organisms jeopardize food security and the livelihoods of millions tied to the billion-dollar fishing and tourism industries. Weakening the ocean's chemical foundation, acidification directly compromises not only the stability of human infrastructure, but the oceans as well.